we'll be moving on to the gradient of a line joining 2 points. Right, so every line has this property called the gradient. Right, gradient is just also known as the slope. Right, it describes the angle. Right, the angle a line makes with the x-axis. Right, makes with the positive x-axis. Right, so let's see this. If we have a Cartesian plane, right, different lines may intersect differently at different angles with the Cartesian plane, right? Like this one. This is a very bad example. Let me give you another example. So let's see these lines. We have this line, we have this line, we have this line, we have this line. So what do you think is different amongst these lines? They all have a different angle they make with the x-axis. If you compare this angle A and this angle B and this angle C and this angle D, what happens? The angle keeps increasing, right? That means that the slope of the first one is very, like, it makes sense. Slope as in the slope of something, where how slopey something is, right? The slope. So if I have a table and then it slopes down at a very steep angle, like it is here, then it slopes. Then at this side, the slope is very small. So right, every line has a slope, and this slope, it's a number. Right? It describes how this line, this integer or number or double or whatever it is, describes the angle, or how slopey the line is. You can just keep that in mind. Right, so in this part of in this video, we'll be learning how to find a slope. We'll be learning how to find the slope of a line. Right. If A and B are any 2 points, then the gradient, right, the gradient will be the same as the slope. Of the line joining AB is given by, so mostly the variable we use for slope is m, and so m is given by the difference. So I'll use triangle for difference, right? So when you see the triangle is changing or difference in y values divided by difference in x values. That's very simple. What it means is just take the x values of a and b, then take the y values of a and b, the points we are considering, and then just find their difference and divide them, right? So for instance, if I have this as a line, and then there is a here, then there is b here. Let's say a has point x1, y1, and then b has coordinates x2, y2. Then to find the gradient of this line, change in y, right? It means this y and then this y, will find a difference between them. So I can just choose to use y1 first or x1 first, y2 first. Any of them you choose, it's still correct, right? So let's just use y2 minus y1 all over. I choose to make it y2 minus y1. You can make it y1 minus y2, right? And then x2 changing minus x1. But what you should know is, if y2 comes first, then x2 should come first. If y1 comes first, then x1 should come first. So yeah, right. So the value here, the number here, 2 here, should correspond with the 2 here, and then 2 here should correspond with 2 here, and then 1 here should correspond with 1 here. You cannot interchange them. This one, this cannot come here, and then this cannot come here, and that would be wrong, right? So when there is two coming first, 2 should come first. When there's 1 coming first, 1 should come first. So that's That's the formula for gradient. That's the formula for gradient. Whoa. So let's gain y2 minus y1. That's the formula for gradient. So you can make it this, or it is also correct when you make y1 first. But when you make y1 first, then x1 should come first. And this is equal to tan theta. Right? It's also equal to tan theta. Where is tan theta from? Right? I'll explain where tan theta is from. So if you want to know where the tan theta here is from, I'll show you. My friend, go up. Right? So tan theta there, earlier I was explaining that gradient or slope describes the angle a line makes with the positive x-axis, right? So this tan theta here, whoa. Wait, what's wrong with you? Right. So this theta that we have here, theta represents the angle between the line and a positive. Wait, can we say positive x-axis? So the same angle makes the move x-axis. Okay, perfect. So this is the gradient formula. This is what we have to memorize. We can just get rid of this. We can just one of it, one of the y's, and then the tan theta, right? So like all other, subject or topics or subtopics or whatever, to grasp the concept very well, we need to solve examples and we need to understand it very well, right? So solving examples is part of the learning process. So here tells you the order of subtraction is very important. So if you are subtracting, be careful. If y1 is here, then there should be 1 here. If 2 is here, then there should be 2 here. They should correspond. And then also, the angle here, we've explained that the gradient of the line is also given by the angle that line not with the positive x-axis. That's what I explained earlier. From the diagram above, the gradient line AB is tan theta. So tan theta, right? From the diagram above, this AB is tan theta. Because see, if you don't get it, let me explain this diagram. We have B and then we have A. Why? If I want this line, right? The difference between this line has y2 here, and then this point here is y1. Do you agree? Because it's from here. And here has x1, and then here has x2. So if I want this and this, it's x2 minus x1. That's the difference. That's from here to here. So if I'm finding this tan theta, we know how tan works. So tan theta will be equal to opposite, which is y2 minus y1, over adjacent, which is a x2 minus x1. So that's where the gradient equation is from, right? Tan theta is equal to this, and that is the gradient. So it means that when I'm asked to find the gradient, I could either use this, right, or I can use this. So gradient can simply be tan theta or y2 minus y1. Let's take these first examples. Find the gradient of the line which passes through the point. So they'll always be given 2 points, and then you'll be asked to find the gradient. So let's see I. In I, we are finding the gradient of P and Q, of line PQ, right? Of the line PQ, because the line passes through P and Q, like this. We're finding the gradient of line PQ. Gradient is given by y2 minus y1 then over x2 minus x1. Let me clean the other bar. Perfect. So let's substitute. My y2, I choose to use q as my 2 and then p as my 1. So my y2 becomes 2, then my y1 becomes 1. Divided by x2 is 7, now my x1 is 1. So I have 1 over 6. So that is my gradient. and then that is the same thing they had here. So we are right. So our gradient is 1 over 6. In the next example, find the gradient of b. You do same thing. We have y, which is y2, which is 5 minus 1 over x2, which is 5 minus x2. So we have 4 over 3 as our gradient, and then that is here. So we are right. Try the last one on your own, and then try these examples to find the gradient of the line joining this. They are all the same examples. Then we could also try these. So get the textbook, Lakiola elective math, then you go through these examples, or you could pause the video and then solve. But these concepts are very simple. Gradients are very simple. Wait, what is wrong? Oh, I repeated the last. Wow, I didn't know, so I repeated. So let's see. Page intentionally left blank. Page. That's crazy. Intentionally left. Oh shit. Blank. Right. So let's move on to the next page. Right. So that's the gradient page. And then the answers are here. So when you are done, you could compare your answers to what's here. You could compare your answers to the answers here. Right. So that's it for gradient of lines. Yes, that's it for gradient of lines. And then there are instances where the gradient will be 0, right? And there are instances where we have no gradient. Let's see. The gradient is it's a fraction, right? It's an expression that has a fraction inside. That means that whenever, because we have y2 minus y1 over x2 minus x1, if this is 0, it will be undefined, right? Because a fraction with 0 as the denominator is undefined, which means that in this case we will have no gradient. There is no gradient for such lines when the denominator here and here are the same and it makes it 0. When this happens, there is no gradient. However, when the numerator is 0, then we still have a gradient, because we can have fractions with numerator being 0, but in that case the gradient is equal to 0. So the gradient is equal to 0. Perfect. So we'll see these examples here. Right, and then in example 5, find the gradient of the line which makes an angle of this with the positive x-axis. So we explained earlier that gradient can be given as this, right, or as gradient is equal to tan theta, where theta is the angle between the line and the positive x-axis. So in this case, we've been given an angle. That means we cannot use this formula. Instead, we'll be using tan theta. So easily, tan theta is 135. So let's calculate tan 135, and that is -1. So the gradient is -1, right? So let's see the significance of gradients. Sometimes gradients are positive, sometimes they are negative. If they are positive, it means the gradient is upward sloping like this. It means that the line goes up this way. If it's negative, it means the line comes down this way. So we can put that in mind. Gradient positive goes up, gradient negative, it comes down. Right. Then we have coplanar points. Coplanar point lie on the same straight line, has the same constant gradient. Therefore, if the gradients between two adjacent points are equal, the points are coplanar. For example, the set points, this and this are coplanar since the gradient, right? So let's see coplanar points. Let's explain coplanar points. When we have a number of points, so please assume this line is a straight line. Let me change the marker to yellow, then erase this one. if we have a straight, that's a straight line, right? It's a straight line, a perfect straight line. If you have a straight line, and then we have some points on them, A, we have B, we have C, and then maybe let's say D. All these points, a line has numerous points, so I just use some points without any pattern. If these points, each pair of these points gives the same gradient, then these points are said to be coplanar points. So two or more points are coplanar, then they lie on the same straight line, right? And once they lie on the same straight line, and the gradient is a property of that straight line, means anybody on that straight line has that same gradient. It's like I want to give an analogy for it. So you can think of it as people inheriting, their surnames, right? The family is a long line. The family is a line. These are members of the family because they are on that line. Once you are in that family, you have the surname, right? So once you are on this point, any pair I take should give me the same gradient. That means that if I find the gradient of AB, it should be the same as the gradient of BC. It should be the same as the gradient of CD. Each pair that I take, it should be the same as the gradient of BD. Any possible pair that I can take, gradient of AD, it should be the same as the gradient of any line at all, AC, or every pair that I take. We have 4, so 4 permutation 2. That will give us, like, I don't know, 4 permutation 2 possible combinations, right? So if this happens, then we say that the points are co-linear points, right? So that's the key word we use here, co-linear. They are all on a linear line, linear points, right? They are co-linear points. So if I ask you to find if some lines are co-linear, like it is here in example 1. So let's say example 1. Which of these sets of lines are coplanar? Are co-linear, right? Sorry, co-linear. It means that take each pair, take them, pair them, find the gradient. Take another pair, find the gradient. Take another pair, find the gradient. And then in the end, you realize that for some of them, all the gradients will be the same. For some of them, the gradient will be different. So for instance, in I, when you take this and you take this, the gradient is the same. So let's see. In I, let's take 2, 5, and then this. If I find the gradient to be 5 minus 1, that's 6, over 2 minus over 3, that is 2. The gradient is 2 for the first two. Let's take this one and then this one, the first and then the last. When I take the first and the last, I have 5 minus 7, that is 12. 5 minus 7, that's 12. And then I have 2 minus 4, that's 6. I also have 2 again. Then now let's take this and then the last one. Let's take the second and then the last. The second and the last, I have minus 1 minus 7, that's 6, right? And then I have minus 1 minus 4, that's 3. So I get 2 again. So the gradient, no matter which pair I select, which pair of these I select, right? Every pair that I take will give me the same gradient. If you encounter this, then those 3 points that are giving you the same gradient, no matter what pair you take, are said to be collinear points. So in this example, these are collinear, these are also collinear, these are not, and these are not. So you should try them for yourself, and then you should try in example 2 to find the possible values of A. You said the points this and this are collinear points. Find the possible values of A. So it's also simple, right? Once it's collinear, all we do is find gradients. So find a gradient, get one expression for it, find a gradient for another equation, find another expression, and then use it to solve this. It's very simple. I don't want to solve it because it's so simple, everybody can solve, right? Right, let me see example 2, right? I'll try and solve example 2. So let's see, we have point 1A we have another point 3, 2, and then we have a last point 4a1. These are coplanar points. The question says it, so you cannot argue against the question, right? You cannot argue with the question. The question has stated they are the coplanar points. Find the possible values of a. If these points are coplanar, sorry, why do I keep using coplanar? It's collinear. Well, if these points are collinear, then should I tell you the secret? Then their gradients are supposed to be the same no matter what pair you take, right? So let's take the first pair, then we'll take this next pair, then we'll get equations for them, then we'll solve the equations, and we'll find a. So let's see. If I take the first pair, then the gradient becomes a minus 2 over 1 minus 3. That is equal to what? A over 2 minus 2. That's the same as, I want to simplify it to 2 minus a over 2, right? That's it. So that's my first one. That's my first gradient. That's the gradient for this pair. Now let's see the gradient for the next pair. So for the next pair, we'll have 2 minus 1 over 3 minus 4a. If you subtract these, you get 1 over 3 minus 4a. Oh, this is the gradient for the next pair. Now, we should find a way and equate these two, right? Since they are the same thing, according to the law of collinearity. I don't know if such thing exists, right? But if, if I'm not a noob, then I can create things, and I just created collinearity law, the law of whatever it is. So that's it. So I can equate these two. So because they are the same, because their gradients, they have to be the same. So 2 minus a over 2 is equal to 1 over 3 minus 4a. Then we'll have to cross multiply. So when we cross multiply, we'll get 2 is equal to 6 minus 8a, right, minus 3a plus 4a squared. Right. We can add these two. So please give me my dashboard. God damn, give me my. Finally, you gave me my dashboard. Right, so we can simplify this. We could make this 2 minus 6. Wait. Let's send the other way around instead. Oh, please no. Oh no. Oh no. I have to find a way to stop this thing. My dashboard. Right, so let me take 2 to the other end so that I have 0 on one end. Right, so I have 0. Right, so I have 4a squared. This and this sum up to minus 12a. Then this goes there, becomes minus, so we have plus 4 is equal to 0. We can divide through by 4, and then we'll get a more simplified form of the quadratic equation there. So let's try and then get that one. So we have a squared minus 3a plus 1 equals 0. We solve these two, you can find a quadratic equation, you can find a. So it's a, how do I do it? A squared, then the numbers are going to be 2 and 1, right? So minus 2 minus 1, no. Minus 2 minus 1, no. Minus 1 minus 1, no. Wait, how are you going to get numbers to get this? It's not 12, it's 11, right? It's 11. So I have to change this. It's not 12, it's 11. 3 plus 8 is not 12, it's 11. That means we cannot simplify. That means we cannot simplify. So it's 11, and then it's 4, and then it's 4. So if you simplify these, we get we can simplify it into we can factorize it into two equations where we have a, right? Wait, where is 11? Yes, a, and then 4a minus 11, right? Is equal to 0. Wait, down. I got a thing wrong. There is a 6 here. Wait, made another mistake here. It's supposed to be 2 minus 1, right? It's minus 1 here. So minus 1, and then this is plus, right? So this is 3 instead of 1, and then this is 6. So this 6 cancels the 6, so we have no more 4 here, we have nothing here. So let me make it good for you to see. That means we get rid of this 4 here. That means we get 4a minus this. So 4a squared minus 11 is equal to 0. That means we can factorize a out. We have 4a minus 11 is equal to 0. And then we will have a being equal to 0, or a being equal to 11 over 4. So those are the values of a. It's very simple. The only principle here in coordinate geometry applied here is the principle of collinearity, which arose from the principle of gradientiality. No, that is all trash, but yes, I just said it. So yes, the rest is factorization, and then simple algebra, and this is gradient. Thank you.